All right, so I am recording. Am I sharing?
Yeah, you share your shit.
Okay, great. All right, so now I have a Moore state diagram that shows input W on edges and output Z in states. Draw the state assigned table, perform a partitioning minimizing procedure, then draw the minimized state table, draw the minimized state diagram. So what I would like y'all to do on your own is to draw the state assigned table. How many of you think you can do this on your own, and how many of you think you need my help to do it? Okay. Okay, so I'm going to give just like 2 minutes for people to do it on their own, and then I will start talking. So I'm going to pause this recording, and I will come back in about 2 minutes. Okay, so now I need to start the recording again. Oh, I didn't want to stop it. I wanted to start it.
Recording in progress.
And share my screen.
Slash thingy, like the /0 and like the /1. What is this exactly that? Is that the output?
No, if it's written on the state, that means, yes, it's the output. If it's written on the state, it's the output. Okay, so draw the state assigned table. So our states are A, B, C, D, E, F. Our input, our next state, depends on our input, where our input is W. We have W equals 0 or W equals 1. And so for each state, you look at the arrows coming out of the state, and that tells you what the next state is for the various values. So when W equals 0, coming out of A, I find the arrow that has the 0 on it, and that tells me my next state is B. If I look at the arrow coming out of A that has a 1 on it, that tells me my next state is C. For B, if it's 0, it goes back to B. And if my input is 1, it goes to E. For C, if my input is 0, it goes to B. And if my input is 1, it goes to D. For D, for 0, it goes to D. And for 1, it goes to C. For E, an input of 0 takes me back to A. And for E, an input of 1 takes me to F. And for F, an input of 0 takes me back to F. And an input of 1 takes me to E. And my output, because this is a Moore machine, it doesn't depend on my input. If my output depended on my input, I'd have 2 columns here. One for W equals 0 and one for W equals 1. But it doesn't. It's a Moore machine. My output is on the state. It depends on the state only. So it'd be 0 and 0 and 1 and 1 and 1 and 1. So is that the state table y'all got, or did I make a mistake?
Nope, that's what I got.
So,
Yeah.
we have two situations. W0. Oh, I guess the state. So, but let's say if your current state A,
Mm-hmm.
your next state is B,
Mm-hmm.
your output would be 0, right?
Output's always 0 if you're in state A, because this is a Moore machine.
Okay, so the output is based on the first column.
For a Moore machine. So if this was a Mealy machine, the way it might look would be like this. Whoops. So the diagram would look different if it was Mealy. It would look like this. And I do need to do that. I'm just making these up, by the way. Okay, so that's showing me a Mealy machine. And the way this would look is I would have my current state and my next state with W equals 0 and W equals 1, and my output with W equals 0 and W equals 1. And so my current states are A, B, C, D, E, F. So if W equals 0 and I'm in state A, my next state is state B, and my output is 0. If I'm in state A and my input is 1, my next state is state C, and my output is 0. If I'm in state B and my input is 0, my next state is B, and my output is 0. If I'm in B and my input is 1, my next state is E, and my output is 0. If I'm in state C and my input is 0, my next state is B, and my output is 0. And if I'm in C and my input is 1, my next state is D, and my output is 1. And in D, I go back to D with output 1, and I go to C with output 0. And if I'm in E, if my input is 0, I go to A with output 1. If my input is 1, I go to F with output 0. And if I'm in F and my input is 0, my next state is F and my output is 0. If my input is 1, my next state is E and my output is 1. So that's a Mealy machine.
So, why did
On this one?
Yeah.
Yeah. And I don't know if y'all had any in homework, but you certainly can, and it is often true in digital logic. I could have a state that machine that looked like this.
So with that extra,
Mm-mm. So I would have a state, I would have two inputs. And so because I would have two inputs, my next state would have x, y equals 0, 0, x, y equals 0, 1, x, y equals 1, 0, or x, y equals 1, 1. So I'd have 4 columns there. And since it's Mealy, I'd have 4 columns in my output as well. Okay, but there was, going back to our original problem, there was a second part of this where it said to perform a partitioning minimization procedure, then draw the state minimized table. So that's going to be the next thing we do. Now, every time I teach this, or SI for this class, I have to review this. and I have not this semester, so we're hoping that finally I did not have to review it. Okay, so we have F. I missed the output for F. The output was 1. Okay, so our first partition is we put all of the states together. So our first partition, P1 or P0, A, B, C, D, E, F. Our second partition is going to be where we divide them up by their output. So we're going to put in A, B in one partition and C, D, E, F in another partition. Okay, so now I want to look at my 0 followers. So if I'm in state A and I get 0, I go to state B, which is in my first group. If I'm in B and I get a 0, I go to B, which is also in that first group. So these two are going to stay together because as far as the 0 followers go, they're going to the same group. They're not going to the same state, but they are going to the same group. So now C is going to B, D is going to D, E is going to A, and F is going to F. So we're going to break this up into putting C and E together and D and F together.
Why are you just looking at
Because I'm doing it a step at a time. I'm going to look at ones next. So next I look at ones. So when W is 1, A goes to C and B goes to E. They're going to the same group, so that's fine. They can stay together. When W is 1, C goes to D and E goes to F. Well, they're both going to the same group, so they can stay together. For D, when W is 1, D goes to C, and F goes to E. So they went to the same group, so they can also stay together. So at this point, I don't need to do another partition because the way they are partitioned right now, I know that everybody in each group has the same 0 followers and the same 1 followers. Because I didn't make any new divisions going from P3 to P4. And then I do it again. If I had made any new divisions here, I'd have to go back and check it. I don't have to check output again. Output's not going to change. But once I divide a group up, then I have to check everything again because, like, let's say I divided up C and E. Well, that would change things because I based a group on that one of them went to C and one went to E, and I said, oh, they went to the same group. But then if I divide C and E, then they're going to a different group. But at this point, I know I'm done. So what this means is I really only need to have 3 states. So I pick a representative from each one. It's not important which one you do. I always do alphabetical. So I'm going to pick A, C, and D. And then that's my current state. And then my next state, let me get more room. A, C, and D. So I pick one representative from each group. And then I'll have my next state. And that is W equals 0, W equals 1. And I have my output. And my output for A and C, for A was 0, and it was 1 for the other two. For A, my next state, if W was 0, was B, except B is not one of my current states. So if it was originally B, I just look and I see which group is B in. It's in my A group, so I'll call this A. And for W equals 1, my next state was C, and that is one of my new names, so I can use that. For C, my next states were B and D. And D is fine, but I can't use B because B's not one of my new states, so what do I use instead? A. And for D, my next states were D and C. And I can use those. Those are fine. So now my new state table just has A and C and D. It was a Moore machine, so I need to put my output on the states. Output was 0, output was 1, output was 1. A, 0 goes back to A. 1 goes to C. For C, 0 goes to A. 1 goes to D. And for D, 0 goes to D. And 1 goes to C. Are there questions on this one?
Can you explain for P3 how, like, I understand for P2 that, like, at W equals to 0, A had the same direction as B. That's why we grouped them together, and like the rest had different, so we couldn't do anything to that. But P3, I didn't understand how did you was able to separate from SE from the.
Okay, so we started with A and B had the different output from C, D, E, and F.
Yes.
Okay, so this next part, so pay close attention, all right, because this is tricky.
Yeah.
Okay, so I start with 0. We're going to do 1 next. So I look at W equals 0, and I look at what group it goes to. So A goes to B. So I'm going to call this group 1 and group 2.
Okay.
So A goes to something in group 1. B also goes to something in group 1. C goes to group 1. D goes to group 2. E goes to group 1. And F goes to group 2. And so that means A and B can stay together. But of group 2, I need to separate out C and E. Because C and E are both going to group 1, and D and F are both going to group 2.
Okay.
So this then, the next partition becomes A, B, and then C and E, and then D and F. Now I'm going to make one little change, and let's see how this changes things. So I'm going to change, let's say that I had instead, let's say that instead of D going to C here, let's say that D went to, D goes to A. Okay, so we have the same thing now. So now this, we did the zeros. So we had A, B, C, E, and D, E. Now we're doing the ones, and now I have three groups. I have group 1, group 2, and group 3. So for A, when W is 1, what group does it go to?
It goes to group 2.
Goes to group 2. Okay? For B, what group does it go to?
2.
2. So A and B can stay together. They're good. Okay, C, what group does it go to?
It goes to the third group again.
Okay, and is that C and F or C and E? That was supposed to be C and E and D and F.
Yeah.
Okay. Okay, so what group does E go to?
It goes to this. It goes to the third group.
It goes to the third group. So C and E are fine, no problem. D, what group does D go to?
D goes to the first.
And what group does F go to?
To the second.
So that means I need to split up D and F. And so my next partition would be AB, CE, D, and F. And you never have to check these singlets again. Once they're all by themselves, you don't have to check them because you can't split up their group because there's just one of them in there.
So first you check W equals to 0, which got you the very first thing, A and B and C, D, E, F. And then you check the ones, which
Then I
check the ones, and that separated 3 different states?
the first thing I did was check the outputs.
Oh, the outputs.
The second thing I did was check the next state when W equals 0.
0, okay.
Then I checked the next state when W equals 1.
Okay.
But in this example, I had a change here. That means I have to keep going. I have to go back and check W equals 0 again. So now I have 4 groups. 1, 2, 3, 4. Okay? For now, I'm going back to W equals 0. What group does A go to?
A goes to, well, W equals to 0?
Uh-huh.
Oh, first.
First, and B?
Second. Oh, wait, B goes to the first.
Yeah, so it's still fine. Okay, C.
In the first one, it goes to B. It goes to the second.
So C goes to the first group, and E.
It should go to the first group, and it does.
It does. Okay, so they're fine. So I don't have to worry about it. I didn't have any change. But it would have been a problem if C went to D and E went to F. Because then I'd have to split them up.
Alright.
Okay. All right. Any other questions?
I got a question for part A, for 2. So,
Yeah.
for our state assignment table, do we have to assign values for our present state, or we can just leave the states by themselves, like just a letter?
I'm trying to remember the difference between the state table and state assigned table. Hold on, let me look it up in the book because there's a difference between the two. So that's a good question. So hold on, because there's a state table and there's a state assigned table. And one of the professors who teaches the class doesn't have a difference between the two, but the others do, and it all depends. So let's see. State table. State assigned table. Okay, so that was a good question, and thank you, because we are not done with this, and we would have lost lots of points, and then we'd be sad, and then you'd say, I'm taking back my nice evaluation of Rebecca. She gets a 0 on everything. She was terrible. Okay, so let's go back. So I hope that you didn't stop listening to this video if you're watching the video, because the difference is, and not everybody uses this difference, but some people do, and so we want to be careful. So the difference between state table and state assigned table is a state table, you can use whatever you want, letters, words. You're just saying what the states are. State assigned table, you're going to use binary numbers. And so if I want to do a state assigned table for this, I don't have to figure out ahead of time how many states I'm going to need. I mean, how many binary numbers I'm going to need, but I like to figure that out just so I know. So if you have one binary number, how many states can you have? 2. So number of binary numbers, number of states. So if I have one binary number, I can have 2 states. If I have 2 binary numbers,
4 states.
yeah, 2 to the 2 or 4. If I have 3 binary numbers, 2 to the 3rd or 8. And that's the maximum I can have. So here I have 1, 2, 3, 4, 5, 6. And so I have to have 3. Because if I only had 2, the max I could have is 4. So I need 3 binary numbers. You can assign them however you want. There is no rule. For me, it definitely is. So I'm going to make A 0, 0, 0, B 0, 0, 1, C 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. So then my state assigned table, 0, 1, 0. So this would be, maybe I'd call them X, Y, Z, 0, 0, 1. It's 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. And then everywhere there's a B, I'll replace it with a 0, 0, 1. So next state, and you usually use uppercase letters for one of these and lowercase for the other, or Y0, Y1, Y2, something like that. So this one, everywhere there's a B, I'd have 0, 0, 1. And D is 0, 1, 1. A is 0, 0, 0. And F is 1, 0, 1. C is 0, 1, 0. E is 1, 0, 0. D is 0, 1, 1. Wait, that's not, I was supposed to be C. C, wait. No, it's D, 0, 1, 1. And now C is 0, 1, 0. And F is 1, 0, 1. And E is 1, 0, 0. And your output is the same.
do we also have to account for like the two other states where there were errors?
You definitely have to if you have to draw the circuit or write an expression. When you're just doing the state assigned table, you don't have to. If you want to be extra careful because you don't really trust the person who's grading your test, you can put them in. And so it can't hurt anything to put them in here. But if you have to write an expression, you definitely have to put them in. So if we had to write an expression for these, we would put in 1, 1, 0, and don't care, 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 and 1, 1, 1, don't care, don't care, don't care, don't care, don't care, don't care, and don't care. And then also for our reduced table that just had 3, we only need 2 binary numbers. And so I'll call this one 0, 0, 0, 1, and 1, 0. And again, you could have a 1, 1 and have these be don't cares over here. And the state assigned table? This one?
No, the one with the divide.
Oh, this is the state assigned table. Yeah, you see, I'm getting it confused. Yeah. Okay.
Is that 0 and 0? Right, for X, Y, Z.
So the next state, if W is 1 for A, is C. And C, so these are A, B, C, D, E. A, B, C, D, E, F. And so the next state when W is 1 for A is C. C is 0, 1, 0, 0, 1, 0.
Then that's
Zero, zero, zero is A.
0, 0, 0. I'm missing state. That 1, 1. For F.
Can someone else answer his question?
That 1, 0. Let's see. Yeah. 1, 0. So,
Is there someone? I have some students that I'm going to be working with in a minute who are down at the door. If someone would go down and let them in, I promise not to start the next question until you get back.
then here with the don't care, they represent states E and what?